Hello, my name is Karen Pugh. I'm a Senior Remote Sensing and Survey Consultant at Environment Systems. We are an environmental and agricultural data consultancy based in the UK. We provide evidence and insight from satellite imagery. Today I'm going to talk to you about how we are using satellite technology to develop a hands-free tool for monitoring extensive grassland systems without the need for a plate meter. Let's start with a crash course in satellite imagery. Broadly speaking, there are two types: optical and radar. Optical satellites capture information from the visible and infrared part of the electromagnetic spectrum. We think of optical sensors as how our eyes would see the world. Optical satellites provide information on crop health and are widely used to monitor grass yield. Unfortunately, optical imagery is affected by cloud cover. When it is cloudy, the image will be compromised, causing gaps in the data. Radar imagery is a bit different. Think of it as how our hands would feel the earth, how rough, how wet, or how smooth it is. Radar imagery provides information on the structure or texture of the land surface. The unique selling point of radar is that it is not obscured by cloud cover, so it provides a continuous and uninterrupted source of data. This is particularly useful for when monitoring grassland fields where cloud cover is persistent and regular data is required. So why do we want to measure grass? Well, grass is an essential crop in livestock production. It is often the cheapest and most efficient form of feed on farms. Farmers need to know how a field is performing so they can make decisions regarding stocking rate, grazing rotation, and fertilizer applications. Grassland is generally measured using a rising plate meter. This is required to estimate daily growth and farm cover, and is often expressed in kilograms of dry matter per hectare. Collecting this data across fields every week can be very labour intensive and are not always representative of variation seen across a field. Radar satellites can be used to measure grass. Here is a time series graph of radar backscatter over a typical grass field. It shows continuous, uninterrupted monitoring over time. Where shorter grass has less biomass, or less structure, the radar signal is lower. But as the grass grows, its structure becomes taller and denser, and this is reflected in the increased radar return to the sensor. In our modelling, we use plate meter measurements collected by sheep, beef and dairy farmers across Wales to model kilograms of dry matter per hectare from radar data. In this graph, the farmer measured data is the blue line, and the radar modelled data is the orange line. As you can see, they track well over time. The model can be applied at a field level to visualise change over time. Here we are looking at modelled data tracking two fields over the course of the season. The orange field contains more dry matter and the blue field less dry matter. The model developed in Wales is also transferable to different environments. Here we are looking at small paddocks in Colombia, roughly 100 hectares in total. Persistent cloud cover over Colombia means there's little scope to use optical satellites for grassland monitoring. In Colombia, we tend to use a radar-first approach to guarantee a consistent source of data to help farmers make management decisions. The model is also very scalable and can cover extensive grassland systems. Here, we are looking at the same model applied to a 50,000 hectare farm in New South Wales, Australia. This demonstrates the potential of the model to estimate average farm cover across an area that is too vast to sample with a plate meter. In summary, both optical and radar satellite data are suitable for monitoring extensive grassland pastures. They can provide data that is usable for farmers to make more informed management decisions. The unique selling point of our radar approach is the consistency of the data. Even on cloudy days, our model will provide a grassland reading. And finally, the technology is highly scalable and can cover thousands of hectares in a single pass, reducing the requirement for more traditional methods, or simply measuring grass where it was not previously feasible to do so. Thank you for listening to my talk. I'll be available at the end to answer any of your questions. For more information, please visit our website. Thank you.